This is geometry. We're in Similarity. We're going to talk about side angle side today. Yesterday we proved triangles similar by angle angle. Today we're going to prove them similar by side angle side. It looks like this wording right here should actually be side angle side. So, what we're going to compare here we're going to look at this side. We look in here. We got 10, 20, 30, 40, 50, 55, 56, 57, 58. So 58 millimeters on that side. This one comes out to be 70, 80, 87. So 87 millimeters on that one. And if we measure our angle, try to get as accurate as we can, it looks like that shoots straight up at about 45 degrees. So we measured that information. Now we're going to come down to another side, angle, and a side. This side trying to get a good measurement in here. Looks to be 10, 20, 25, 26, 27, 28. And then this side looks to be 42. All right. And we should measure our angle. If we extend this side up, it looks like it goes right to that 45. So this is 45 degrees. So one thing we know for sure is we have a pair of angles. These are called the included angles because you have two sides and you have the angle in between those two sides. So it's called the included angle. Now we have to look to see what's happening about these sides. All right? So I like to take the small number divided by the bigger number. Notice that this is the smaller of the two, and as the shape gets bigger, it's going to become the smaller number of the larger shape. And when we look at this one, we have 28 divided by 58, and that's coming out to 0.48. Now, when we do this next measurement, it might not work out perfect, but we're expecting this to be pretty close to what we just got. So let's find out. So that is 42.87. And that is crazy. That is the exact same set of calculations. So that is some awesome measuring. That usually doesn't happen to be that perfect, but it is 48. That's very reasonable. Okay? So we have a set of proportional sides. The sides are proportional, and the included angles are congruent. When that happens, I can draw in my third side. I can look at what's going to happen to the angle. When we trace this out, we measure that angle. When we bring it, well, I got to draw this one first, I guess. And I bring it over here, it's going to match up with that one perfectly. So I know my angles are the same. So my angles match up perfectly, and my measurement, my third side, let's see what I can come up with here. That looks to be just about 60. Super close to 60. And this one, just about 29. Maybe 29 and a half. So we're going to compare the 29 and the 60. 29 and the 60 gives us not quite the same decimal we had before, but it is 0.48. So that worked out well. So we're noticing that if we start out with side angle side, that's all the information we knew, that when we draw in the rest of the triangle, the second and third angles are going to be congruent, and the final sides are going to have the same ratio as we had before. The only reason why they may not be absolutely perfect the same is because of the human error of drawing your line, the thickness of the line, measuring off of millimeters. Okay? So we just showed that we started out with two corresponding sides of two triangles. They are proportional. And the included angles were congruent, the 45s. We were able to show that the triangles were similar by side, angle, side, congruence. So that is a new way that we can prove triangles similar. Let's come on down and take a look at the information that they give us. Here's a pair of triangles. We have to see, is there enough information to prove the triangles are similar to each other? Well, I see the big X, and a big X like that tells me that I have vertical angles. So I know that angle LVM, you can't just say V, you got to use three letters, is congruent to angle UVT because of vertical angles. So now we've got to check out the sides. Well, let's look at the 8. The 8 is the smaller side, the 8 and the 14. It's the smaller side of this triangle. So it must, as it gets bigger, it must turn into the smaller side of the other triangle. So it's going to be compared with the 28. So 8 over 28, that can be reduced by the same number to the top and the bottom. That would become 2/7. That ratio doesn't mean anything all by itself. So let's get the other bit of information. Let's look at the longer side. As the small triangle became the big triangle, the angle stayed the same and the sides got longer. So the 14 became the 49. The 14 becomes a 49. we can reduce those both by 7, and we get 2/7. That worked out perfect. These are the same. They have the same scale factor. So that is proving the triangle similar by side angle side. So what triangles are similar? We went VU. So VU, they're doing the big triangle first apparently. VU is down the small side. Then we went up to the other angle. So when we label it here, we have to go down the small side. So VL and then up to our other angle M. Because they wrote it VUT, we have to write it VLM. Let's take a look at our next set of triangles. I notice right away that I have a pair of angles that are exactly the same. They're both 76. I have a pair of small side here and a small side here. So let's first say that angle F is congruent to angle U. I also know that 9 is the small side, 21 is the small side. I can reduce this by a common number. 3/7 is my result. That by itself doesn't mean anything. We have to compare it to the larger side and the larger number. So 18 and 42 looks like 6 goes into both of those numbers. 3 and 7. Perfect. They're the same. They have a common ratio. So the sides are proportional, and of course the included angles are congruent. So FGH, we went down the long side. Started at 76, went down the long side. So when we name this triangle, we have to start at the 76, which is angle U, go down the long side, which is V, and then we finish up at W. So the order you write the letters is very important. Let's compare this last set. Again, immediately I notice this big plus in the middle. That plus gives me vertical angles. So what I know for sure is angle SUT is congruent to angle EUD. That's what we know for sure. Now we're going to look at the smaller number. And I noticed that they're both 16. There's not a smaller number. So I see something failing here already. But we'll take the smaller number. And we'll take the smaller number. So 16 over 39, I don't see that reducing. And then we'll take the largest number, 16, and we'll take the largest number, 40, and I know that that can be reduced by 8. I get 2/5. These are not the same. The sides are not proportional. I do have a pair of angles that are congruent, but I do not have proportional sides. The small triangle did not grow into the large triangle evenly for both sides. It was close, but not quite. So triangles are not similar. Now on the flip side, we have this triangle proportionality theorem, and in the converse of the triangle proportionality theorem, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two triangles proportionally. So what that's saying is that if we have this line that is parallel to one of the lines and it intersects the other two lines of the triangle, sides of the triangle, then it's going to divide these sides proportionally. The top part over the bottom part is supposed to equal the top part over the bottom part. And the other statement here is called the converse. It works the other direction also. If a line divides the sides of a triangle proportionally, then we know that it's parallel to the third side. So let's go ahead and test that. I see I have a pair of sides parallel. That's our given information. We want to figure out what UQ is. So, I know that the sides are going to be divided proportionally. So my RQ over QU should be equal to RS over ST. So I have 10 over QU and 12 over 6. So I'm going to cross multiply. That gives me 60 and 12 times QU. Divide by the 12. And QU is 5. So this would be 5 right there. Which makes sense. 6 and half of, 12. 12 and half of 12 is 6. So we have 10 and half of 10 is 5. They're divided proportionally. Let's come test it down here with solving. We know that we have parallel sides. BE is parallel to CF, and CF is parallel to DG. We need to find the three missing sides. So one side that we can find, we could find X. So if we're going to work with X, the tricky part with this is trying to decide what triangles you're going to work with. So if this was BE and this was DG, we're not using the one that's in the middle there. We're not using CF because the big triangle has 18. The small triangle is X for that corresponding part. We know that this length is 4, and 10, and 3 is 13. That's 13. We know the triangles are similar because if the lines are parallel, then we have alternate interior angles that are congruent on both sides. So that's enough to prove the triangles are similar. So we can do a proportion. We can say that the X over the 18 equals, that's a small triangle over the large triangle. So we have to use the small number over the large number. When we cross multiply, we get 72 That doesn't go in there evenly. That doesn't reduce at all. So let's at least look at the decimal version of this. 72 divided by 13, that gives us 5.5 or 5.54. That was solving for x. Y would be done in the exact same method. We have the big triangle, which is a length of 18. We have this medium triangle, which has a side of y. That is CF. That is DG. And this is angle A. We know this side here goes from A up to C, so that's going to be the 4 and the 6, which is a length of 10. And the other side is a total length of 13. So I'm just redrawing the picture so I get a good visual of what's happening. It gets a little confusing when you have the extra letters and lines in there. So I'm drawing them just to be two triangles. I know the sides are parallel. So I know I have alternate interior angles that are congruent. I have two sets of them. So I know the triangles are similar. So I can write a proportion. The small triangle y over the large triangle 18. Those are corresponding parts. Small triangle 10 over the big triangle 13. Those are corresponding parts. So I cross multiply. I really only have to divide one direction because my 13 is already in bottom. So 10 times 18, we know that's 180, and we're going to divide that by 13. We get 13.84. So that's our y value. And then our last one is to solve for z. If we have a pair of parallel sides, okay, we're not using big triangle, small triangle here. We have two sides parallel with a 4 and a 6 and a 5 and a z. So we're going to figure out, since the sides are parallel, I know the sides are divided proportionally. That is 4z equals 30, and divide by 4, z equals 7.5. So we found our x, our y, and the z.